Hi, welcome back to Moose in Chemistry. This is electron configuration of manganese. Manganese is element 25 on the periodic table, so the atomic number is going to be 25. All right, the atomic mass number is going to be 55. So now our protons equals our atomic number, so that's going to be giving me 25. And since all elements are electrically neutral, manganese also would have to have 25 electrons. But what about its neutrons? Well, let's look at that. We have AMU minus protons equals the number of neutrons. So we have 55 minus 25 would give me 30 neutrons. Pretty darn snarly, eh? All right, now, before we can get into electron configuration, we have to look at our subshells like S. S subshell can hold 2 electrons, P subshell can hold 6 electrons, D subshell can hold 10 electrons, and the F subshell can hold 14 electrons. And we're going to use something called the diagonal rule right here. This diagonal rule here is going to take care of the off-ball principle where we fill the lower shells first, right? So we're just going to follow the red arrows down just like this until we run out of electrons. Okay, so let's go. 1s2, 2s2. Pretty cool so far. 2p6, and then 3s2. All right, we're really rolling now. 2p6, 3s2, 3p6, and also 4s2. Now, what about the next one? 3d5. Okay, that's our electron configuration. That was pretty simple. Just follow the diagonal rule, and you're going to make it. All right, now Hunds Rule deals with the suborbits, right? You have to put an up arrow in every suborbit in that particular suborbit before you start that down arrow in that suborbit. Well, for 1s, it's just up and then down. And 2s, it's just up and down. Now watch us with 2px, 2py, 2pz. 1, 2, 3. All the up arrows are now in the suborbits. Now we can do the down arrows. 4, 5, and 6. Pretty darn cool, huh? 3s, up and down. Same thing with 3px, 3py, 3pz again. 2, 3, 4, 5, and 6. Just totally amazing. 4s, up and down. Now, we have 3d5, so let's go ahead and fill these in. 1, 2, 3, 4, and 5. Well, that's it for normal orbital rotation. Okay, what about noble gas notation? What's the nearest noble gas? Well, it's argon. So we're going to put argon in here, AR. Pretty amazing, huh? So now, let's look at our last shell, our valence shell. And here it is. Here is our valence shell right there. And so we're going to put in numeric order here. So we're going to put in 3d5, 4s2. Now we're going to do the quantum notation. Well, okay, remember that manganese is in the D block, right? If it's in the D block, it's going to be N minus 1. When you look on a periodic table, it looks like manganese is in period 4, but it's not really in period 4. You go 4 minus 1 equals 3. So our N value is actually going to be 3. Okay? The angular momentum number, it's in the D block, so that number is going to be 2. Cool. Now the magnetic number, it's going to be the 5th element over in that D block, right? So -2, -1, 0, 1, 2. So it's going to be 2 for the magnetic number. So put a 2 there. This last arrow right here is going up. So the spin number is going to be 1/2 positive. Remember what Pauli's exclusionary principle states, that no two elements can have the same set of quantum numbers. And they don't. Well, listen, you guys be snarly, and we'll see you back here at Moose in Chemistry!